I think it's also helpful for us to define that what is under that ground resistance testing banner here too, because I mentioned a multifunction ground test instrument. Three tests really come to mind here, and I'll give a shout out to a fourth as well too. Resistance to ground testing. This is going to be, I have an electrode or an electrode system, being a bunch of electrodes that are interconnected and show up as parallel to the Earth. This is going to be that fall of potential test, but fall of potential is one method for resistance to ground testing. There are other methods out there that are more applicable in specific scenarios. Outside of that are soil resistivity testing. If I were going to put these in a more logical order, I would put soil testing first. This is going to allow me to perform a measurement of soil resistivity or resistance. We turn resistance into resistivity for then designing a system or even maybe troubleshooting what measurement I'm receiving on a resistance to ground measurement. This can be performed usually a number of different ways, but most of the time we're subscribing to the winner test procedure, which is a 4-pole test method for soil resistivity testing. It's simpler, easier to perform, but there are other methods out there, of course. The last test procedure, or the second to last, is not a resistance to ground or even a soil measurement at all. This is going to be those, point to point, or equipotential, or also could be called continuity measurements. We're testing here a bonded system, right? For those of you that have done this in a substation, this can be, 1,000 measurements or more in some cases, where I'm moving just throughout the substation, testing individual components of the bonded system and measuring their resistance. I want to see that obviously be very low, so that everything is interconnected well. The last measurement I'll mention that can fall underneath this category, very similar to the resistance to ground measurement, is going to be like step and touch potential measurements. Now, these are largely more or less calculated anymore. However, we can perform these measurements with a 4-pole ground resistance test instrument, or other testing procedures now exist to validate that our design meets our specification.
Any thoughts on that there, Tom?
I think that pretty much sums all of them up. I would like to say that the 4-point test set that you have can perform the soil resistivity. That's the quality of your soil. That determines what kind of conductors you need to put in earth, right? And how you need to bond those conductors to your earthing system. And so that 4-point test set will perform that test, and then the 4-point test set or the 3-point. Why get the 3-point? Just get the 4. And that will perform your fall of potential. Your point-to-point can be done with your 4-point test set. Commonly, people do that by bonding your voltages and currents together, and then they just have to measure your lead resistance. I'm going to give you a little tech tip right here. I personally don't like that method because that's a coiled up bundle of wire and you're performing an impedance test. And as you string out more wire, what do? You just change that coil's inductance and you just change the entire measurement of your resistance. And so you measure that wire, what are you going to measure it with? You're either going to jumper it together at the test set and just press start. Oh, I got 1.4. Okay, write it down. I'm going to subtract 1.4 from everything. You spool that coil out, and what do you get? It's not 1.4 anymore. It's 1.8 because you just changed your inductance. So I personally I might take like my test set and set it right next to the probe that I'm testing at 1, and I'm going to point to point to another one, right? And so I have a really short lead here. Who cares about a short lead on a point to point, right? We care about the 100-foot leads. Those are the ones that really have a value that makes a difference. So then I'll run 200-foot leads out, and that'll be a separate voltage and a separate current, just like you do with your DLRO. Right? And so that's how I'll typically run that. But the fall potential and the point-to-point and the resistivity can all be done with a 4-point test set. You can also do the point-to-points with a DLRO or a 100-amp inductor or whatever you need to do. Quite often it's done, customers might require a 100-amp or a 300-amp inductor just because they want to verify ground grid integrity. They want to check the
Yes.
joints during the fault current. So that might be part of your requirement. And then your step in touch is usually going to have to be done while the system is off, unless you have an off frequency injection. And so, because otherwise you'll just measure noise during the whole time. So you got to make sure your power grid or your substation's off, and then you can measure your step in touch by doing a current injection or some kind of method along those lines.
Right.
In all honesty, if you're checking your grid and you can honestly go ahead and probe throughout your substation with a fault potential and just make sure that you have a good earth nearby. Most of the time, step in touch is usually not too much of a problem. And I don't know. There's other meters out there that could probably do that a little bit better than a 4-point test set.
I 100% agree with that.